Okay, let's just dive right in. You hear these terms thrown around all the time, right? Artificial intelligence, machine learning, deep learning. They're everywhere. But what do they actually mean? And more importantly, how are they different? Well, in this explainer, we're going to clear all that up. We're going to demystify these buzzwords once and for all and see exactly how they all fit together.
So here's the big question. Are AI, machine learning, and deep learning all just fancy ways of saying the same thing? It's a super common point of confusion, and you know what? It's totally understandable. But the short answer is no. While they are definitely related, they are absolutely not interchangeable. It's better to think of them like members of a family, not a list of synonyms.
The absolute best way to picture this in your head is to think of those Russian nesting dolls. You know, the ones that fit inside each other? Artificial intelligence, or AI, is the biggest doll. It's the whole field. Then you open it up and inside you find the next doll, machine learning, or ML. And then tucked inside that is the smallest, most specialized doll, deep learning, or DL. It's a hierarchy, with each one being a more specific piece of the last.
All right, so let's start with that biggest doll, the one on the outside. We're going to take a closer look and get right to the heart of what we really mean when we talk about artificial intelligence.
At its core, AI is really the grand ambition. It's this huge field of computer science that's dedicated to one massive goal: building machines and systems that can do stuff that normally requires a human brain. We're talking about things like reasoning, solving tricky problems, making plans, and even understanding language.
So yeah, AI is this massive umbrella term. It covers pretty much anything that tries to mimic our cognitive abilities. It's usually split into two big categories. First, there's narrow AI, which is designed for one and only one specific task, like a program that's amazing at chess. Then there's the one you see in the movies, general AI, which is the sci-fi dream of a machine with human-level intelligence across the board. Just so we're clear, we haven't achieved general AI yet.
But even without full-blown general AI, its impact is already enormous. You see it in advanced robotics, the chatbots you talk to for customer service, the fraud detection systems that protect your bank account, and even in incredible tools that help doctors diagnose diseases. It really is all around us.
Okay, let's open that first doll and move to the next one in the set. You see, early AI often relied on people writing millions and millions of if this, then that rules by hand. It kind of worked, but it was really brittle and couldn't handle anything new. A different approach was needed. So let's zoom in on the solution: machine learning.
So, if AI is the big, overarching goal of creating intelligence, machine learning is one of the most powerful ways to actually get there. The magic of ML is right there in the name: learning. Instead of a person writing endless, rigid rules, they feed an algorithm a ton of data and just let it figure out the patterns for itself. It learns to make predictions and decisions on its own.
So how does it really work? Well, ML loves what we call structured data. Just imagine a perfectly organized spreadsheet where every single column is neatly labeled. Think of a database of house sales with columns for square footage, number of bedrooms, and the final price. Now, it does need a human touch to get started, to train the model and make corrections. But the golden rule of machine learning is simple. The more data you can give it, the smarter and more accurate it gets. And believe me, you use this every single day. When Amazon suggests a product you might like, or when Netflix perfectly recommends your next binge watch, that's machine learning. It's looking at what you've done in the past to predict what you'll want next. Even your email spam filter is a classic example of ML working behind the scenes.
All right, it is time to open that final, innermost doll. See, machine learning is awesome with neat, tidy spreadsheets. But our world is full of messy, complicated data, like pictures, videos, and sounds. To deal with that, we needed an even more advanced technique. And that's where we find the most powerful subset of them all: deep learning.
Deep learning basically takes the whole learning from data idea and puts it on steroids. It does this by using something called artificial neural networks. These are really complex systems with many, many layers that are directly inspired by the actual structure of the human brain. You can think of it like a digital brain, where layers of nodes pass signals to each other, spotting more and more complex patterns with each new layer.
So what makes deep learning so special? Well, for one, that layered structure means it can learn with way less human hand-holding than traditional machine learning. Second, it's an absolute champion in handling that messy, unstructured data we talked about, things that don't fit in a spreadsheet, like photos, audio recordings, and plain text. The catch? It's incredibly hungry. It needs absolutely massive amounts of data and some serious computing power to do its thing.
And when we say these models are complex, we are not kidding.
The most advanced ones can have, and this is wild, literally billions of parameters. You can think of them as billions of tiny little adjustable knobs that the model tweaks and tunes as it learns. That mind-boggling scale is what lets them understand such incredibly intricate patterns.
And all this power is what's fueling some of the most futuristic tech we see today. The vision in a self-driving car that lets it spot a pedestrian, that's deep learning. The facial recognition that unlocks your phone, yep, deep learning. The ability for Siri or Alexa to actually understand what you're saying, you guessed it, that's deep learning too.
Okay, so we've met all the dolls in our set. We've seen what makes each one unique and why each one exists. Now for the moment of truth. Let's put them all side by side for the ultimate comparison.
This table really pulls it all together. Let's break it down. First, scope. AI is the whole playground. ML is one specific game in that playground, and DL is like the star player of that one game. Next, data type. ML likes things neat and structured, but DL is the pro at handling unstructured stuff like images and audio. And here's a huge difference: human input. ML needs a human trainer, but DL can pretty much learn on its own. And finally, that all leads to complexity, where deep learning is by far the most complex of the three.
So, we've broken it all down. We've seen the dolls within the dolls. But why does knowing the difference between all these terms actually matter? What's the big takeaway?
At the end of the day, the most crucial takeaway is this hierarchy. These aren't three competing things, they're a progression. All machine learning is a form of AI, but not all AI is machine learning. And all deep learning is a form of machine learning, but definitely not the other way around. Understanding this structure helps you cut through all the marketing hype and see what's really driving the technology we hear about every single day.
Knowing this helps us see how our world is being reshaped from simple automation all the way to these incredibly powerful brain-inspired networks. So, I'll leave you with a question to think about. Now that you know the difference, which of these technologies do you think is going to have the biggest impact on your life in the next 5 years?